back again to our last guest for today. It's Zach Jackson. Um, I guess a lot of people know who Zach is, and he's the maintainer of Webpack and of React Universal and the Redux First router and a lot of other things. And he's the creator of the Module Federation. And to list all his stuff and open source technologies maybe takes the whole session time. So I will pass over to you, Zach, and it's great that you are here. And yeah, here we go.
All right. Well, yeah, it's fantastic to be here, and thank you for having me. So I guess we'll get right into it. So I'm here to speak about Module Federation and a bit beyond. So for anybody who doesn't know the basics, since this is a Micro Frontend conference, I imagine we're all at least familiar with the concept of federation, but just in case. The idea is you can share and import code at runtime between different independently built or deployed parts. So you've got on the one side, that's kind of what it looks like to configure the plugin, and on the other side, this is what it would look like to consume it. So hopefully we all have seen this somewhere before, or at least a bit familiar with the concept. All right, so since we wrote this, which I think we came up with it about 4 years ago, it's grown quite a bit in that time. Lots of big logos have kind of started to use it, and through this kind of process, I think we've learned quite a bit from our user base. The big thing that we did learn is that it's time for a redesign. So some of the things that we have noticed in the last couple of years, the needs of applications really have outgrown the original design of it. The software has become more complex. We have new bundlers entering the space now. Webpack isn't necessarily as appetizing to select when you're looking at your build infrastructure choice. And I think there were a lot of workarounds and hacks that either I've had to implement or users have had to implement that would have been nice to clear out of the way. So to kind of give you an idea on what was behind the redesign, so the company that I currently work at is ByteDance. And we have quite a large infrastructure team over there, and we are also one of the largest users of Federation globally. So our infrastructure team has a very specific mindset for how we solve or write our infrastructure tools for the larger company to power all of the applications that we have. So I pulled some quotes just to kind of help everybody understand the mindset or of how the company operates, or the level of scale or velocity that we try to do our application releases at. So essentially, we needed something that would keep up with this kind of momentum. And since Federation has been a big powering point for the company, what we're trying to look for is how we could build out more organizational enablers versus just a developer tool. My favorite quote, though, is this one from Harvard Business Review. And it kind of says, why has nobody been able to replicate the success of the strategy on how we release software into markets and how we're able to operate so efficiently? And their conclusion was that other companies haven't implemented the organizational enablers that helped us overcome the kind of siloed mindset, which really inhibits the collaboration.
Zach, sorry for the interruption. Yeah. There are a lot of comments on the channel that the guys cannot see your presentation. So
okay, let me stop sharing and reshare my whole screen, and let's see if that works.
There was only the first page of on the whole time.
Okay, my bad. All right, is it moving now? Are we seeing?
Yes, it's moving. So.
All right, sorry about that. Sometimes Keynote gets stuck. All right.
No problem.
All right, I'll play back through these basics. Here we go. What it looks like. Companies that have been using it, the growth that it's had over the past couple of years. Lots of familiar logos we've probably seen in there. Our redesign reasons. All right, getting into our quotes again. I'll just give everybody a moment to kind of read these. But I think a nice one here is like the middle one, where we launched 12 entertainment apps in the first few months. Company, and we did this mostly just to test these apps across foreign markets to look for opportunities. So a lot of kind of what we're trying to do with these organizational enablers is drive down the cost of exploration. If we can explore really broadly and R&D really broadly and launch a lot of applications with the cost of launching them reduced, we can obviously iterate and find more markets to go into, more ideas that will work out without really an excessive cost. This is kind of what our infrastructure team tries to do, is reduce the cost, speed up the iterations so that the business can test more things faster and launch them a lot quicker. And then the quote from Harvard Business Review that I really liked, again, really it's about removing things that inhibit collaboration and that can help break us out of the silos. So back into where I would left off. This is kind of the scale. Since ByteDance is the largest user federation, this is kind of the scale that we're operating at, and the demand that we've kind of got on our infrastructure and on the tools and on the architecture. We've got over 15,000 front ends. We have 10,000 plus front end engineers. We do around 10,000 deployments every week into a production environment. We have thousands of remotes at thousands of versions. And on the business end, we have over 1,000, user-facing business products. This is either in the App Store or on websites, or I guess it would be really mainly those two. So this is where we kind of started to come out with Module Federation v2. So it was a major rewrite. The big things I wanted to introduce were something kind of like a hook lifecycle or an SDK. I wanted to pull it out of Webpack so that we are more agnostic. And a big goal here was trying to increase engineering throughput, improve the deterministic stability of Federation. If anybody has used it before, you might know if you share something, let's say we're going to share React. Every time you reload the page, you'll always get the right version of the module you want, but you won't necessarily be able to guarantee who's going to give it to you. So if everybody's sharing React 18, it might come from application 1, and if you reload the page several times, it might decide to come from application 2 later on. There was no guaranteed deterministic route of the module sharing. It would just give you the thing that was going to be within the Zephyr range. And then we also wanted to kind of improve the user experience aspects of it a bit, from loading things, dealing with waterfalls, or if you've dealt with the SSR issues before, CSS flicker is challenging, other various challenges like that. Even preloading it is also kind of tricky in the V1 design. So in V2, these were kind of some of the areas we wanted to tackle. So the biggest area that I like is this new Runtime API. So usually you would have your plugin where you can configure your application or your federation options, but you wouldn't have a way to really do it outside of a static compilation plugin. So in this new runtime, it's essentially what we've done is we've taken what you could do at compile time and we've kind of brought that into the runtime area. So we've actually inverted how the whole process of federation works. Federation is really now just a library. And what happens is the bundlers implement the library and kind of just fill out this object for us. So whatever you put in the plugin, more or less just goes into a init call inside of the bundler runtime, and it just does the same thing. So we've extracted that out into a library so that you don't need to have a compiler plugin to actually do anything that you would do with the compiler plugin. We've also introduced, so on the one end, we've got, here's what it would look like to add remotes. And then, again, using the Runtime API, if say I wanted to add shared modules, this is kind of the avenue that you would be able to use as well. So you can either just, use this lib key that we have on here, and what lib is if it's synchronously available. You can just add a variable, like if you were going to use an external or something like that. And then we also have a getter key, which is basically if it's async. So if you wanted to dynamically import React and not actually choose React from an existing host or something like that, then you could use that option as well. We do have a lot of this written out in our docs, and we do have new docs that'll kind of show a little bit later. But these are kind of the two main aspects that we've introduced into the Federation runtime for end users. So beyond just inside of the runtime, we've introduced what was my favorite part, which is called the runtime plugins. So the idea behind these is, the best way to kind of put it is, imagine you've got like express middleware, but for require. So as an import is happening, maybe I want to decide things on the fly. Maybe I don't know the URL of the remotes until I'm in the environment. So it'd be nice to have some kind of middleware layer where before request is made for a module, I could figure out the environment, figure out what's supposed to happen, um, or just change the order of operations, change what it's going to go and do. You know, when I'm loading shared modules, maybe I want to mess with that. Before I'm about to load a shared module, maybe I want to do a lookup on the application to determine certain things. I would say a good example of how I've used this on the more advanced end was I will use the onload hook and I'll use the load share hooks. And I can, when I'm importing a module, I could go in. Oh, sorry, it's early for me. Before I go into a module, I could see, is the thing I'm about to import a different framework? So the example I've used in the past is like, let's say I've got a React 17 and React 19, and I'm going to import a component from the 17 repo. Now, let's say this is a scenario where I do actually need two separate copies of React. If anybody has used Federation, you'll know that's not really how it works. You kind of have to have singletons for everything. But with a runtime plugin, what I can do is I can see that there's an incompatibility. They need two different major versions, and Simver of a singleton is not going to pass it. So inside of the runtime plugin, I could set up one where I say, well, once I get the module, I'm going to actually intercept it. And instead of just passing it back to the host, instead I'm going to automatically mount it onto a ref, and I'm going to give the host kind of like a adapter component, and the host is going to send props into the thing you're importing, and we're just going to re-render it, kind of like you would do with maybe something kind of like single spa, or something like that, where you're not necessarily using the JSX style, but as the end user, you are still doing that. So you're still just importing it and working with it as JSX, but technically you could be importing Angular code, or you could be importing Vue, or in any other direction, but you wouldn't know that you're not importing React, and you wouldn't interact with it in a non-React style, because the runtime plugin would allow you to build adapters or translation layers between the modules themselves. So that's like a more advanced scenario of it. And I do have a couple simpler examples just to kind of show you. And before, I just want to reiterate that these are runtime plugins. So I can add them through if you saw in my previous slide here, this config also takes a runtime plugins option, and you can just add an array of functions. So it is at runtime that you can utilize these. In the compiler plugin, we have a little an additional option on there called runtime plugins, and it just takes an array of require resolves as well. So it's the same kind of concept, but it's not a compile time solution. It's a runtime middleware layer for Federation. So some examples that I've got here. Let's say I wanted to override shared modules. So this is just a simple React component. You'll see there, Lodash has now changed from 3 to 4. And I'm just using stuff that I have in memory from reading the new Federation APIs that I can access. And you can see I just swapped out React DOM with a different version of React. And all of this is just based on the living data from what these two applications have available. And using the runtime plugins and creating a little UI, I can read the information available, and I can instruct the runtime to change how it behaves. And every time I hit save, I'll pretty much refresh the page. And I'm using something like local storage just so that I have a place to store the rules that I'm setting to override the default way that module sharing or anything else is resolved inside of module federation. So this just kind of demonstrates the control layer that you can have, or the amount of flexibility that you've got available. You'll also see it shows like where things are used in and so on, so you can actually see who's using the parts and pieces like that, which I thought was pretty cool as well. So another great example here is, let's say you have offline remotes. If something goes down, this is always a very big question. How do we fix it? What do we do? You can sometimes use a dynamic import to catch the remote if it's offline, but it's not always guaranteed that it'll work. I think the scenario where I see it crash the most often is if the remote entry isn't even there to begin with. I think if you're trying to access something out of the remote that doesn't exist, you can try catch it with the import catch. But if the container doesn't exist in the first place, I think this causes a hard error in the runtime code. So anyway, this has always been a very painful issue of how do you really protect against it. So what we've introduced is a hook called error load remote. So if you remote isn't online or a thing you're trying to access out of it doesn't exist, the error load remote hook will throw. And you can intercept this hook here and you can determine how do you want to handle it. The whole idea behind error load remote is it gives you the error information and all of that, but if you return a module-like function from error load remote, that's what the host ends up consuming. So if the remote is offline or I can't get to it or it doesn't exist, in this scenario, what I'm going to do is I'm going to use this get module function and I'm just going to have it return a React component that renders the error message as a string. So in the next example here, this is kind of what that looks like. I have two apps. App 2 is never online, so I just start app 1 and I go to it, and I would expect this to throw my application. But instead, the app will render, and all I see is that instead of button 2 showing up here, I'm getting an error message saying, hey, it's offline, and this is why it's offline. But the application continued to operate and function. So another example of using these kind of runtime plugins is if you want something, usually what I find is users have asked for dynamic remotes, but there's different kind of scales of dynamic remote. There's I just want to change the URL of the remote entry at the startup of the application, but I know I'm importing button and I know I'm importing header, and you kind of know it's static imports everywhere, but it's a dynamic connection to a certain remote depending on an environment or a user or authentication or something like that. So the pain was is if you wanted that kind of flexibility, you would usually have to go to fully dynamic remotes, where you're using either like a window get or a load remote or something like that, and you can't use require and import from anymore just because you want that bit of dynamicism at the top of the application. So using a runtime plugin, you can create that. So in this scenario, I've got my init call, and I'm pretty much just creating like a hash map above. And I can loop over it and I can check, well, if anything exists in the override, then, then I'm going to use that and replace the existing application with some kind of subbed in other option. So in this scenario, I'm just kind of mocking like an API call out with a promise all, but in reality, this could be a API endpoint that you're reaching out to, or something on the window where you store your configs or anything else. But the whole idea is during initialization, I have an async hook where I can choose to loop over the remotes and rewrite what they are, where they're going, what I'm asking for, while still preserving the static imports throughout my whole application. So this is just using the init hook, and you would be able to do something like that. This is kind of what it looks like in that example. So you'll see in the previous one, I've got some local storage here for button where I have my override. So when I click the override, I'm just storing something in local storage and I refresh the page. And in doing so, I have 3 applications. I have app 1, app 2, and app 3. And what I'm doing is when it goes green is I'm still importing app2/button, but the runtime plugin allows me to rewrite that to say, okay, well, actually, you're going to be connecting to app 3's remote entry and loading button from them. So, you could use this for different version deploys of remotes or for green-blue testing, kind of like I'm demonstrating here. But the idea is in your app code, you're not changing your imports. You're just able to change what they mean just in time. So another kind of example of dynamically mapped remotes, this one is a little different than the previous one that I showed you. The main reason is you'll see I'm using this before request hook instead. So before request really means that I'm going to do the logic right before the bundler, as it's making the import call. If I do it in a init, I'm saying do it up front. I know everything up front. If I say before request, that means as late in the application lifecycle as possible. So if you needed the application to start up and maybe you needed auth to happen and the application to run in order for you to figure out, what will the third page click down be, you could use before request to rewrite these only just in time once you have data that you've collected throughout the application. So it's kind of similar, but it's a different part of the life cycle, but you can still achieve the same concept or the same thing. So another really nice feature that we've introduced is remote federated types. So if you're a TypeScript user, we have hot reloading types across remotes. You'll see in here, I'm adding types. I go to a different app. Immediately when I'm there, you'll see it went red. I fulfill the types. Now, if I go back and remove the types from my remote, and if I go back here, you'll see my host is already throwing a type error. So we don't need to install anything. We don't need to configure any additional plugins. This is just built into Module Federation 2. It works, pretty much in every direction, and it's, kind of what you would expect. Remote type hinting across the board. Now, after I recorded this video, we did introduce something new, which is the ability to do dynamic type hinting from the browser. So this works really well if you're import froming your code. Like I have import, remote one button, so there is some static analysis I can perform and I know what to go and find. But what happens if you're using, the Federation API and you're saying, load remote variable, and there's nothing to statically analyze. So I can only do it in the browser. So what we've done is we've taken the API and we've also exposed it into the browser runtime. So that means if you went into the browser and you just pulled up your browser console and you did something like, let's just say underscore federation dot API dot register remote, app3, and you put in the remote, when you hit enter, if you come back into your IDE, you will see that the types have synchronized just like they're doing here when I'm doing it statically. But for any information we can't statically analyze, the browser will flush the information out in development mode and send it back to our type broker, and it will pretty much do the same thing that it would do at compile time, but we can do this at runtime with the browser filling in the information that we can only find out during the browser's execution stage. We've also introduced proper fast refresh and hot module reloading. So this was also a big issue that everybody's complained about forever. And you'll see in here now I have two different apps and I can change them however I want. And you'll see the demo app is updating as we're making the changes here. Let's see if I go and delete this. I put something else in here and we pop it open again. And, once again, it is working. And if I change the title, instantly, as you would expect, fast refresh works across the different app boundaries. What's actually cool is in a later tool I'll show you that we've released, you can actually do this in deployed environments. So I can mix production with fast refresh and develop against production with local modules and hot reload and fast refresh a production environment without impacting anybody else. We've also introduced something called the runtime kind of lock files, or this capability for it. And at ByteDance, this is how we manage our thousands of remotes and thousands of applications and keep them stable. Is we have something kind of we call it internally VMock, and VMock is essentially our kind of control plane for managing all the apps and the dependency graphs of everything in here. And what it actually does is it's using this lock file system that we've developed. So we have the JS remotes that you can see like that bottom one, but we also have introduced the JSON remote protocol. When you're using the JSON remote, we can do things like hot reloading, type syncing, things like that, because we can perform look-aheads on the module graph before actually executing any code. The other benefit is it allows us to replay Webpack's algorithms on an edge worker or something like that. So we can calculate we can calculate how the app will behave without executing the application. Therefore, we can create log files for it. So this is kind of what it would look like. This would be our edge server, and you can see I've just got, read manifest. This could be fetch, or in VMock, this is fetching. So it fetches all the JSON manifests for the remotes. And then we can call the generate snapshot from manifest. And pretty much it'll give us back a payload that we can insert into the DOM or send back over a API call. And when it's received, the application will not behave any other way beyond what the snapshot tells it. So it won't, if we wanted to do a deployment, for example, and this is kind of how things work, we don't actually move zip files around our infrastructure to redeploy anything. All that is actually happening is that this snapshot changes. So if we want to update production, our deploy is actually just a database record change for this snapshot in a table. And that is the deployment, because all the code technically already exists somewhere on the internet. So nothing needs to really happen beyond telling Federation that its new snapshot or its new lock file has been updated, and it should now respect the behavior of the new lock file. The final part of this is kind of what it looks like to insert this into Federation using a runtime plugin. So we're obviously hooking into some helpers that we've got, we parse it, and then we just inject it into our native, our runtime helpers here. And register the global snapshot, and then the application becomes deterministic and immutable, and it will never change unless the snapshot changes. So getting into a couple other tools, we've got Chrome Dev Tools here, the ability to change certain aspects and see when our hot reloading works in here. You'll see some type hinting that kind of pops up in this space as well. You'll see in our UI, you can see the relationships between these different tools. You can see as you change things in the code base, the UML will update, and you can see kind of like what's going on inside of, or who's consuming what parts are exposed, how are things connected to each other. Another cool example, this is using hot module reloading in a kind of deployed environment. So I'm able to say, take a production application and I can use a module proxy. And what I'm going to do is I'm going to replace it with a red, it starts out with a red button, and I'm going to replace it with a different version of that button that I have locally. So I enable my module proxy and I can say, okay, remote 2 equals localhost 3003, and I just pointed at the remote entry. And now this deployed application is replacing one of those references with my local reference. And I'm able to, again, perform normal HMR or anything else, just as if I was in localhost, but the host can be in a production environment using production versions of React and all of that, and fast refreshed, everything else should still work. So you can find all of this stuff on the doc site. Modulefederation.io has been updated, so we're still adding more to it, but it should give you a pretty good idea. Places to go, recipes we've got, the way we configure it, all the new options that are available, the bundlers that are supported, and so on. So, like I said before, inside of ByteDance, we have something called VMOG. I think in general, if anybody has worked with Micro Frontends before, you probably would have noticed that it is a little tricky to manage these, especially the deployment order of operations, or controlling it, or seeing who uses what and where. So it was hard, and what we have gone off and introduced is this thing called Zephyr. So I'm going to give you an example here of what it looks like between a normal application and a Zephyr application when it comes to deploying something to stage or production, or anywhere that's not your machine. So in the traditional one, you'll see we've done a commit and a push. And, we're going into, let's say, Netlify in this case, and we're waiting for CI to get running. And, then we'll sit here awkwardly for however long it takes, and and it'll deploy out the application that you want. Now we've seen CI's picked it up. So the reason I'm kind of demonstrating this is, even at ByteDance, we found a lot of the cloud deployments that we need to perform are it's impacting our iteration loops for things that we don't really care about at this moment. So if I need to see it in stage and I don't plan on deploying this PR to production or this commit to production, then why am I waiting the amount of time for all of this to run, when all I want to do is see what's going on right away? So it took about a minute to do that. Now we're going to switch over and we're going to use a Zephyr one. So I uncomment the plugin, I run a build, and the application is deployed. So there was no CI, there was just the build. And this is off on the cloud in any environment you want. Now let's say we're going to change something. What's our iteration loop time to get back to a deployed environment? And we're redeployed again. And so it took us, I think this is using a Webpack, it took us about 1 second to get it back into a remote environment. We do it again, and there you go. And so we can keep on doing this. It takes about, and I think when we switch over to faster bundlers, we get this down to, I think the fastest we're able to bring the iteration loop down to is, I believe it's about 200 milliseconds delay between when you hit save and between it's back in a cloud environment. Now, this is not just pushing something straight to production, even though you could push it to production. This actually can be artificially gated. So we've put in the rules so that you can determine if every time you hit save, what do you want it to do? You could push this into production, but you can set up the rules to say, well, just because the build is there doesn't mean it can be shown to everybody else. So maybe we kind of work in reverse, where we say, well, the code is already available immediately, so I can work with it, I can iterate on it quickly. But in order to get this code or this module snapshot to update in a deployed environment for other users to see, you might want to wake up your CI and have it just go and rerun your unit tests, or use our TypeScript syncing system and just validate that your type contracts are still good. And if those artificial gates pass, you could then update the database record and say, okay, well, now the thing that I just hit save on, that can become production. But the whole point is that you don't really need a whole lot of infrastructure around here to actually see what's going, to get things out. It's very fast, it's very quick to iterate on, and you can obviously make it as safe or unsafe as you would want, or as your organization would want through setting up organization rules. But being able to bring down that iteration loop speed is, it's been a very important aspect for us at ByteDance, and having this ability to solve a lot of problems around order of operations with micro frontends is quite nice. So I think one of the other big things I do want to call out is with this cloud thing is we don't actually sell you or want to sell you cloud. So the idea behind Zephyr Cloud is it wants to use your existing cloud infrastructure. If you're on AWS, it just wants an AWS key for the accounts that it can help manage the resources. There's not really any markup on compute or any of that, because we don't want your cloud to begin with. It just kind of wants to manage the cloud that you've got better and help you see what's going on and speed up that iteration loop on whatever system you use. Cloudflare, AWS, Azure, things like that. Another cool thing that we actually have been working on introducing in this product is this concept of kind of compute offloading. So imagine you need to deploy something and you need it really quick. Then maybe we could say, let's push it to a Cloudflare Edge worker. Because Cloudflare Pages, the point of presence takes a while. So we can't immediately roll it out from Pages. But I can put it into the key value stores in Edge worker. And then soon as the point of presence is more readily available, we can promote the deployment into Cloudflare Pages automatically for you. So you could have something, say, like AWS, Cloudflare workers, Cloudflare Pages, and depending on the workload or depending on the demands that you need for the application, Zephyr could dynamically determine which compute nodes to use. So it can move things from AWS back to Pages, from Pages back to AWS, depending on whatever workload is required. You just connect your clouds and you can state where you want it to go, or you could have it do something like compute offloading and tell it maybe optimize for cost or optimize for latency, and it will figure out the fastest locations to put the different parts of your application for you. So to give you an idea on what the visuals look like on this end, if we click into something in Zephyr and inside of VMock and at ByteDance, we have a very similar kind of concept here. I can click into a node and I could see from my app, I could see what it depends on and who's depending on it. And I can see the different modules or different files in each code base and what they're linked to. So I'm aware of the version, who's using it, and where they're using it. If I don't want to see that much detail, I can obviously zoom back out and look at the node views here to see the relationships or the directions the connections are moving in. And yeah, that essentially gets into Zephyr. So one nice thing about working at ByteDance is we have a huge amount of applications, and everything that we do is really around organizational enablement for the business. So we're driven pretty much by business metrics. The only reason that we exist, the only reason we do any work is, does it improve the momentum of the business, and do we meet the demand put on our infrastructure, on our tools, and on the capacity of what they can do. So one of the nice things that we've do with a lot of our infra tools is we benchmark them for the value they actually return to make sure we're doing it right. So these are some really great metrics I was able to collect from my company on what we've seen on average across the thousands of remotes, hundreds of teams, thousands of apps that use Federation. Overall, we've seen 60% reduction in our build times. In Webpack, we've seen about 8 to 10 minute savings, about 2,500 CI hours per project a week, roughly 80% reduction in initial JS size. The biggest number really here, I would say, is the bottom three. On average, across all of our teams, we've witnessed a 300% increase in engineering output, that including a 80% reduction in code rollout time. Since all of our code is just a module snapshot, it went from taking, I think, about 10 to 15 minutes to walk code through environments to under 2 minutes to get any code across any of the 1,000 apps that we need. And probably the biggest number here is going to be, we have about 500 deployments or product deployments to end users per project per year. And at our scale of 1,000 applications, we're looking about 500,000 more features getting into the hands of end users per year than we were before, with the only change being moving those over to Federation, powered by something like VMock or Zephyr. If you do want to read a bit more about Zephyr, you can go to zephyrcloud.io or connect with the team on Twitter. And now let's rewind a little bit. So I said there were some new bundlers coming out and so on, and Federation was made bundler agnostic. So about 5 months ago, we introduced Federation support to Rspack. So for any of you who don't know what Rspack is, it's designed to be a drop-in replacement for Webpack written in Rust. So I'm one of the maintainers of Rspack now, and I work on the core team there. And what we see is Rspack is about 11 times faster than Webpack, and it should work with the majority of Webpack plugins, loaders, configs that you currently have. The average user takes less than 1 hour to migrate from Webpack to the Rust toolchain of Rspack. Obviously, Federation works, and all the other things that you would think of would work in there. And you can kind of see the difference in speeds. The one thing that's really strange, and I do need to go and speak to the team and understand why, but the development build, the production server is actually, the production build is actually faster than the dev build. You'll see my dev one's 149 milliseconds, but to do a production optimized build, it only took 70 milliseconds. So I'm not quite sure how that's possible, but you can kind of see the deltas between what the Rspack one looks like and what the Webpack speeds look like. And you can see we're looking at 700 milliseconds, 2 seconds, so on and so forth, versus, the slowest one is 230 milliseconds. So that kind of gives you an idea on the speed increase. But Rspack also does keep getting faster and faster. I think about a week or so ago, about a week or so ago, we dropped the speed down by another 10 to 15%. So some of the things that we're looking at adding into Rspack in the future, a big one is going to be remote caching. So we're going to be introducing remote distributed caching, and it will be a free open source addition to Rspack. So you can host the cache server yourself, and you can share that cache server among whoever in the company you're working with. If somebody's already built 80% of the application, you make a branch, change the other 20% of it, you're really only recompiling that 20%, and you're pulling all the other modules out of the remote shared cache. We are also looking at, and this is a bit of a stretch goal, but looking at distributed compilation. The idea behind that would be, imagine if we could offer a fixed time on builds. So usually the bigger the application, the slower the build becomes. And it's usually kind of like a linear growth. If it's 50,000 modules, it might take 4 seconds. If it's 100,000 modules, it'll probably take 8 seconds. So what if we wanted to say, we want to guarantee that every build always builds in 2 seconds? So with distributed compilation, the idea would be you could invoke more instances of Rspack on your cloud, and we could introduce something kind of like a client and daemon, where the Rspack client could break up the graph, dispatch the work out to the daemons. They each build only one small section of the graph, push it into the cache, and then the client pretty much just reassembles the cache and the module graph, and then just seals the build and emits the chunks. So in theory, you could wake up, 10, 100, 1,000 build workers, and you could, parallelize the compilation across multiple backends as well, and speed that up. I think for most users, you probably won't need that, but if you do have a really large application, that would be very nice to be able to control that build time regardless. So one other cool piece of news that kind of popped up with Rspack is, I think it was just last week. It was when I was at Render ATL. So I think it was last week. We actually ended up winning Breakthrough of the Year at JS Nation. So that was a really awesome piece of news. I just wanted to kind of share out here, and we're very honored to have received that for Rspack. We also do have like a slightly larger family around Rspack. If you do want to check it out, we do have a big Rust toolchain that we've kind of rolled out, but I'm only going to touch on one or two that are more relevant to Micro Frontend conference. So obviously, if you want to check out Rspack, rspack.dev. If you don't like Webpack style configuration, we also have kind of like a Vite flavored one called rsbuild.dev. You still have all the power of Rspack, but you have the simplicity of their configuration style. If you do want to read a bit about the rationale behind it, you can always go to our Git org, and we did have a really good discussion, or just Google the rationale behind creating Rspack, and you'll see the document pop up, and you can kind of read all the research and development that we did, everything else we rewrote before deciding on Webpack's API and rewriting it in Rust as the only kind of way to support our business. So kind of getting into the ROI of it, since we do have this data here, overall, some really impressive numbers. Biggest ones are across the board at our company, we have an 80% reduction in our CI cloud costs. About 30 minutes saved per build, per project. About 200 hours a day on CI per project, and per developer, they save about 7 hours a day, assuming they only ever did 5 dev cold starts in that day. So we kind of measured every time it takes for you to press save, every cold start, every time you tear down the server and start it back up. We kind of track all of that in our company to figure out our business metrics and find the areas where we can shorten the gap on time burnt unnecessarily. So it might look like a small number, but monitoring all this, we've ended up at saving about 400 hours a year. Just assuming on 5 kind of developer startups, plus all the saves that you do in between. I think we had a bench at about 100 hot module reloads a day. So anyway, but this kind of gives you the idea of the ROI that we have seen across the board here. We have also worked with other big companies who have adopted Rspack and used Federation and things like that. And from when they adopted it, they saw about a $32 million a year reduction in their operational expenses. Or capital expense, engineering time, pretty much. So including CI, including the time it takes to start their dev server, all of that. I think the loss was about $120,000 for every day that they didn't use Rspack. And then when they switched over to it, that was the gain they ended up getting from it. But we've also spoken to a few other companies as well. Another one has told us that they are saving millions of dollars in bandwidth costs per year since they've switched over. And at ByteDance, our own return on investment, a conservative one, has been Rspack's value is in the hundreds of millions of dollars in ROI for us. That's across engineering hours, cloud costs, and the user experience lift that kind of comes with improving the user experience. So some of the tools we've also introduced around our little family that are kind of, I'd say not, these are relevant to every developer, I feel, not necessarily Micro Frontend, but a big one is if anybody's used Bundle Analyzer, it's been very painful when apps get complicated. And so we've obviously had this issue as well. And so what we ended up writing was something called RSDoctor. This works for Webpack and Rspack, like it says in the title. But do I not have my other slides in here? I don't think I do. All right, but what I would do is if you want to check it out, definitely go to rsdoctor.dev. Nice things that it gives you is how long things take to compile. Where's your tree shaking not working so well? Are there unused exports in your build? And you can go and inspect them. You can see the timing of everything. How long does it take for, SWC loader to work, or a post CSS loader, or a SAS loader? Which files are slowing down your build? What's resolvers are inefficient? Flame charts that kind of show up in the UI of this thing on the back end. Any warnings that we find, type inspection, whole bunch of other things we've kind of packed into this tool to give us something kind of like a one-stop shop to understanding what modules are used, duplicated, where's the build size coming from, where's the build speed being lost. The last kind of thing I want to point out here is if you are a micro front-end user or Federation user, ByteDance also has its own meta framework. This is what we use internally. And again, we're the largest user of Federation here, so it has been very refreshing to stumble across that we owned this, because we've been able to tighten up that integration between them. And we do have some PRs we're working through the system now that are going to introduce a lot of server-side rendering capabilities into modern JS, specifically around Federation. So things like being able to automatically discover the roots of other remotes, or being able to deploy an empty app shell to AWS and everything else is just put on S3, and the app shell never needs to be updated because the root discovery is automatic. Making sure there's no waterfalls, making sure it's efficient, making sure the CSS never flickers, kind of all the things you would expect from a normal SSR experience. We're moving from our internal copy of modern JS to our open source copy of it. And like I said, that process is in the works. So if you are looking for a good, tight experience in this ecosystem, this is what we use, and this is what we need to work well. And we kind of own the supply chain of all the parts. And this is what I'm hoping we can push in to make a really good, solid React micro front-end layer for kind of the bigger companies like us who need these things. So last thing, a bit on our roadmap. Across the board on the Rspack end, we are going to be introducing a NPM packaging solution called RSlib. The closest way to describe it is like a meta framework for authoring packages. So a big problem we've had with Webpack is it's never good at making ESM, tree shakeable ESM. So we've been working with the Webpack Foundation and obviously the Rspack team to introduce a much better ESM output format that is designed to be tree shakeable and designed for package building. So we'll be bringing those capabilities forward under Rslib, which should offer you, a build framework for making libraries. On the Federation end, I'm busy working on import maps. We've got an ES build Federation plugin that is almost done. We have a roll-up one that's also in the works. And then we already do plan to work with the roll down team from Vite once roll down gets a little bit more matured to add Federation into the Rust end of Vite as well. We've got the V1 of Rspack coming up next month. On the Rspack end, we're also looking at import maps inside of Rspack. Multiple output targets, so being able to build CommonJS, RSC, web worker, browser, all from a single build instead of needing multiple builds. Tree shakeable package builds, and those features will show up in powering our Rslib. On the Federation end, we've got we're introducing something called the Module Federation framework capabilities layer. The idea behind this is taking a lot of the ideas from single SPA and adding them into an additional point of Federation. So the ability to have mount points or router bridges between multiple apps. So I could import an Angular app and I could forward the React router props and context into Angular. And I could also pull them back and forwards to allow multiple apps and multiple routers to act as one and to mount and unmount accordingly, but using Federation as the underlying solution for doing so. A nice one we're also looking at is Rspeedy. So I believe this is still very early on in development, but inside the company we have a lot of apps, a lot of native apps, and we actually have our own meta framework for React Native app development. And we are looking at open sourcing that sometime this year or maybe leading into a bit of next year. But the idea would be almost like a alternative to Expo with a very light micro VM for all the JS stuff that needs to be done on a full Rust tool chain, And of course, I have got my ulterior motives here of when we release this native app framework, I'm definitely going to try and do what I'm doing to modern JS to it and make sure that we have a really tight module federation powered React Native framework right out of the box. And then, of course, on modern JS, we are looking at SSR, root discovery, and other niceties over there. And like I said, that PR is already passing our CI. We're just cleaning up a couple extra areas of it. But anyway, that's kind of the big update on what's going on here. Thank you. And yeah, stay tuned for news coming across various channels or at conferences or just on our docs.
Okay, thank you, Zach. Great talk. And sorry again for the glitch at the starting point.
No, it's all right.
We have a couple of questions, so we will start with the questions from Alvaro. Do you need to configure some DTS files or something in the tsconfig JSON? I often get the error module not found when importing my remote module.
Yeah, so the main thing you would do is if you're using Module Federation plugin from Webpack, you would stop using that and you would npm install Module Federation /enhanced. And then if you go to our docs, you can just look, I think you can look on the announcement page and or on the guide, and it will show you TypeScript. And it'll basically tell you, cool, here's how you enable TypeScript. There's a little guide on it. But basically all you do is you go to mapped paths and you would say @mftypes, I think. And then what we do is we read your TS config and we inject all the types. We pull them from a zip file, and the remotes carry a zip file with them in the manifest mode. And essentially, we synchronize all the types back onto your file system. So, yeah, that's how you would solve it. If you're using normal federation, then you would switch over to V2's version, which is again not part of Webpack, not part of Rspack. We have an independent ecosystem that we can control and maintain and move forward, and then we just have the compilers implement our runtime and not drive it.
Okay, one more question from Kathrik. Going via manifest way, wouldn't that have an extra hop to server to load manifest first and then remote entry?
Yeah, so I think the main thing with the manifest on our end is because at ByteDance we've got VMock on our back end, so the manifest thing was kind of a solution to give to the open source because they don't have our server infrastructure. And the V2 was originally actually an in-house fork that they had built and bound directly to their infrastructure. So since we can't release our infrastructure as a whole, what we've done is we've figured out a way to provide this to you. So yes, this will cause a secondary load if you want all the additional benefits, but I'm pretty sure if you're looking at several other solutions out there, they all involve overhead loads to do this. How we ideally deal with it is we inject it in right from the edge worker, so we pre-calculate it, so there's no need for any JSONs to come down because we can compute the result of the JSONs on an edge worker, and we insert the snapshot, which essentially means that Federation doesn't think at all in the browser. It just listens and does what it's told exactly, similar to like a monolith or a statically compiled graph. But yes, you will have to be conscious of, if you're using the JSON protocol, you will introduce a secondary request that is unavoidable unless we start evaluating remote code on your servers and everything else, and that introduces another big challenge. So with everything, there is a drawback.
Okay, thank you, Zackary.